Hey, let's review your practice test. First thing is don't forget your name, as usual. If you don't put your name, you can't take your test. Now, if we're going to do a dilation by a factor of 1/3 on the first shape, what we want to do is we want to draw a line from your center of dilation, in this case it's point C, to each vertex. And there we go. And then for each of those lengths, I'm going to do about 1/3 of that length. Now, I'm not looking for you to take out a ruler, although you can, but we're just going to go about 1/3 of the way for each one of these. And there's about 1/3. Here's about 1/3. And there's about 1/3. And it should be similar if you draw it in there correctly. I might not have drawn the greatest artistic ability there. Now in question number 2, we got these trapezoids, and I see I've got 2 right angles. Not sure about the others. They kind of look like they are. But let's look at the sides. And if I pick the smallest vertical side, I'll do the one between the right angles, 9.6. That would correspond to 6. And then I'll do the opposite side. I'll say 12.4. Does that correspond to 7.8? Well, the easiest way to tell that if it's a proportion is to cross multiply. So if I take 9.6 times 7.8, okay, so if I take 9.6 times 7.8, I'll get 74.88. Does that equal to 12.4 times 6? And I can see they're close, but they're not quite the same, are they? So my answer is no, they're not. The sides aren't in proportion. And now let's take a look at number 3. And I think at number 3, we'll draw these out first off. So we got triangle ABC. Whoa. Triangle ABC. And triangle DEF. In fact, I think I'll even switch colors on that. Now I'm told angle A is 51 degrees. I'm told side AB is 14 and side AC is 20. And I'm told in triangle DEF, angle D is 51. Side DE is 16.8. And side DF is 24. Are these similar? Well, we can definitely see we have the angle here, don't we? So we know 51 is the same in both of them. Now the question is 14 to 20, is that the same ratio as 16.8 to 24? I think I'll do the same thing I did in question 2, is to see if they are in the same ratio, to see if that's a proportion. Let's cross multiply. So 14 times 24, and notice we get 336. Then if we take 16.8 times 20, we get the same answer, don't we? So, are these similar? Yes, they are. I always forget to change back to a pen. So, yes, they are. And my reason would be side angle side similarity. Now, let's take a look at question 4. We're told P to Q is 12. I want to find the measure of the dilation of P prime Q primed with a scale factor of 3/4. Well, in other words, we're just going to say 12 times 3/4. 12 times 3/4, 3/4 is 9. On question 5, we want to find the value of x, which is the side of the big triangle. I'm going to raise it up just a tad here. So 2x, notice the triangles are similar because we have angle-angle similarity. So 2x is to the length of the whole side of the big triangle. I'll say that's 10.8. And we'll compare the small triangles. Well, N to L would be 2x minus 6.5 then, wouldn't it? So I'll say that's 2x minus 6.5 is to 4.8. And then let's solve for x. I think I did this one more complicated than you needed to, but I chose this way, so we'll do it this way. So we're going to multiply both sides by 10.8 and 4.8. So notice my 10.8's reduce. I take 4.8 times 2. Well, that'll be 9.6x. On the other side, my 4.8's reduce. So I'll take 10.8 times 2. And I'll get 21.6. So I'll get 21.6x minus, take 10.8 times 6.5. And we'll get 70.2. Now we'll just solve for x. So a minus 21.6x from both sides. Notice we'll get negative 11 minus 9 is 2. So I get negative 12x equals negative 70.2. So I'll divide both sides by negative 12. And x will be 70.2 divided by 12. And we get 5.85. And that's one way to do it. I like that way just as much as anything.